Today we will study some important properties of Laplace transformation. There are four important properties. First we are going to study is linear property. Yeah, we can say it linearity property of Laplace transformation. This property says if Laplace transformation of a function of x is denoted by f of p, then Laplace transformation of alpha f1x plus beta f2x is defined as alpha f1p plus beta f of 2p. Since we know, ऐसा तो बोलते ही है Laplace transformation of function of x is by f of p. So what is linearity property says Laplace transformation of alpha f1x plus beta f2x can be written as alpha f1p plus beta f2p. Now we will prove this. How we define a Laplace transformation of using this Laplace transformation of alpha f1x plus beta f2x p can be written as 0 से infinity alpha f1x px to the power minus px dx plus 0 से infinity alpha beta 1 plus beta f2x e raised to the power minus px dx. We know the Laplace transformation of fx is defined as 0 से infinity f of x kernel e raised to the power minus px dx. So using that property of Laplace transformation, which is definition, we can write it. It can be, because since we know that integration is linear, it can be written as alpha f1x e raised to the power minus px dx plus 0 से infinity beta e raised to the power minus px f2x dx, or we can say it alpha 0 से infinity e raised to the power minus px f1x dx plus beta 0 से infinity e raised to the power minus px f2x dx. We know this is a Laplace transformation of f1x and this is Laplace transformation of f of 2p. So we can say the Laplace transformation is linear. Now let us take some examples to clear it. We have to find like Laplace transformation of cos hyperbolic ax. Since we know that cos hyperbolic ax, we can write it as e raised to the power ax plus e raised to the power minus ax over 2. Using this property here, we can write it as Laplace transformation 0 से infinity e raised to the power ax plus e raised to the power minus ax over 2 e raised to the power minus p of x dx. Now it can be written as, using the linearity property, 1 upon 2 0 से infinity e raised to the power ax e raised to the power minus px dx plus 1 upon 2 0 से infinity e raised to the power minus px to the power ax dx minus of ax which is 1 upon 2, 0 to infinity. Solving this, it will be like e raised to the power minus p minus a over p minus 0 to infinity plus 1 upon 2 e raised to the power minus p plus a over minus of p plus a 0 to infinity. Simplifying basic by the integration. Then we will use the solve it using the second shifting property. Now what is this? This is 1 upon 2. Applying infinity it becomes 0. And applying 0 it is 1 upon p minus a. Similarly here plus when applying infinity it is 0 and this is 1 upon 2 p minus a. Solving this we will get p over p square minus a square. This is the Laplace transformation of cos hyperbolic ax p. Now, if we solve it using the second shifting property, we can write it as Laplace transformation of cos of hyperbolic ax p equals to Laplace transformation of e raised to the power ax plus e raised to the power minus of ax over 2 p. Further we can write it Laplace transformation of 1 upon 2 Laplace transformation of e to the power ax p plus 1 upon 2 Laplace transformation of e to the power minus ax p. Using the previous result which are earlier derived, we can write this. This is 1 upon 2. What is the Laplace transformation of e to the power ax? It is 1 upon p minus a. What is the e to the power minus ax? It is 1 upon 2 1 upon p plus a, which is equals to p over p square minus a square. This, we can solve the problem using Laplace transformation basics and using the linearity properties. Similarly, we can find the Laplace transformation of sine hyperbolic ax. Sine hyperbolic ax p, which is equals to a over p square minus a square. Here the condition is p should be greater than mod of a. अगर p mod of a से greater than नहीं होगा तो it will become 0 और our integration become divergent. So it is always कि p should be greater than 0 condition fulfied. This is about the linearity property of the Laplace transformation. Now we will study first shifting property. प्रॉपर्टी ऑफ लिनियरिटी ट्रांसफॉर्मेशन ये क्या कहता है? यदि हम लाप्लास ट्रांसफॉर्मेशन ऑफ फंक्शन एफ एक्स को एफ ऑफ पी से डिनोट करते हैं, द लाप्लास ट्रांसफॉर्मेशन ऑफ फंक्शन e raised to the power ax f of x p is defined by f of p minus a where p should be greater than a. We will write this condition always. So how we can prove this? If we taking the Laplace transformation of e to the power ax f of x p, so using the definition of the Laplace transformation, we can write it 0 से infinity e to the power ax p minus a x f of x dx. It can be written as p is changed by p minus a, can be written as f of p minus a. It is clear? So if we multiply a function y e raised to the power ax, then the Laplace transformation is f of p is changed by f of p minus a. If we take here minus ax, then what will be? It will be plus. So we can solve it using the first shifting property. Some questions, these are the basic properties. We have to remember these properties to solve the questions. Now let us take some Laplace transformation of e raised to the power 3x sine 4x p. We have to find this. Now we know that Laplace transformation of sine ax is what? It is a over p square plus a square, can be written as p square over a is 4, p square plus 16, a over p square plus a square. It is clear? Now using the first shifting property, we are multiplying our function with some n e raised to the power ax. Here a is 3, e raised to the power 3x sine 4x p. So what is, if we multiply function by e raised to the power ax, here e raised to the power bx, then what is it here? F of p minus a. Here f of p is this, and here a is 3. So what will be p minus 3 square plus 16. So using first shifting property, we have proved that e to the power 3x sine 4x p equals to 4 over p minus 3 square plus 16. It is very easy and I think it is clear. Now we will come to second shifting property of Laplace transformation. Second shifting property of Laplace transformation. ये प्रॉपर्टी क्या कहती है? यदि हमें पहले से गिवन है कि Laplace transformation of some function f(x) is denoted by f of p, और हमें कोई फंक्शन गिवन है another gx which is such that f of x minus a when x is greater than a and 0 when x is less than 0, then Laplace transformation of g of x p is given by e raised to the power minus ap f of p. यहाँ क्या है, आपको फंक्शन एफ एक्स अलग से गिवन है, उसका लाप्लास ट्रांसफॉर्मेशन माना एफ पी है. जी एक्स एक ऐसा फंक्शन है जो कि एफ एक्स को यूज करके डिफाइन किया हुआ है इन सच कंडीशन एफ ऑफ एक्स माइनस ए व्हेन एक्स इज ग्रेटर देन ए एंड 0 व्हेन एक्स इज लेस देन 0. देन आवर लाप्लास ट्रांसफॉर्मेशन ऑफ दिस जी एक्स फंक्शन इज गिवन बाय e raised to the power minus a p f of p. This f p is same as this p, this f p. Now firstly we take some example, then prove this. Now we have to given a function g of x equals to sine of x minus pi by 3 when x is greater than pi by 3 and 0 when x is less than pi by 3. Now let us assume that we just don't know about the second shifting property of the function, then how we will derive the Laplace transformation of the function gx using the basic definition of the Laplace transformation. Applying the Laplace transformation's basic definition here, what will we get? Laplace transformation of this function gx. P is what is? Here the function, our generally this is 0 से infinity e to the power minus px g of x dx. Now here when the function is 0 से pi by 3, then the limit is 0 से pi by 3, the function gx is 0, and then pi by 3 to infinity, our function is sine of p minus pi by 3 is to the power px dx. This will be our, this term is 0 because this is 0, so here we left pi by 3 to infinity sine of x minus pi by 3 e raised to the power minus px dx. Now solving, यहाँ पे we can write here x minus pi by 3 equals to some function t, then b of x equals to b of t. Then the limits change to when x equals to pi by 3, t from 0 से infinity, when x equals to infinity it becomes infinity sine of t e to the power px, so x is replaced by e to the power minus p, x is p plus pi by 3 dt. Can reason है e to the power p pi by 3 0 से infinity sine of t e to the power minus pt dt, which is what? Again Laplace transformation of function sine. It can be written as e to the power minus p pi by 3. What is the Laplace transformation of sine? Then we can say it is Laplace transformation of sine kp, which is p over p square plus a square. So here a over p square plus a square, here a is 1, so it can be written as 1 upon p square plus 1, so that p should be greater than mod of 1. It's clear? So we have first, what we have, we use the basic definition of the Laplace transform and solve our integration. Now we will use the second shifting property of the Laplace transformation. Here we have to find Laplace transformation of g of x, where our g of x is sine of x minus pi by 3 when x is greater than pi by 3, and 0 when x is less than pi by 3. Now we have to find the Laplace transformation of this function. Now here we know that Laplace transformation of function sine of x is our 1 upon p square plus 1. So here our this function x, अगर we change y to here a is pi by 3. Function gx is defined as function f of x minus a. So here a is pi by 3 and function fx sin x, which is Laplace transformation, is given by 1 upon p square plus 1. If we use the second shifting property, it is says e raised to the power minus ap minus pa, a our pi by 3 and Laplace transformation of function of x, which is 1 over p square plus 1 square. So using the second shifting property, the solving this function is very easy. We can find it in some second the answer. So here we will use the second shifting property. Now we will prove the second shifting property. Second shifting property, and if our gx is some kind of function f of x minus a, then x is greater than a, and 0 when x is less than a, the Laplace transformation of g of x हमें फाइंड करना है, तो we can write it as using the definition of the Laplace transformation. We can write it as 0 से infinity Laplace transformation of gx, g of x e to the power minus px dx. Now g is not continuous function, it is breaking at the point x equals to a, so it can be written as 0 से a. Our function has 0 minus p of x dx. When a से infinity, our function has the value f of x minus a to the power minus p of x dx. This becomes 0. Now here, if we take x minus a equals to some function p, then d of x equals to dt. Putting it, this becomes 0 due to this 0. Now f of x minus a, putting x minus a equals to t, our limits change to when x equals to a t from 0, when x equals to infinity t become infinity. F of x minus a become f of t e to the power minus p. From here x is what? X equals to a plus t, and dx is dt. So it can be written as e to the power minus ap, because it is independent of t. It is the outer side of the integration, and that is 0 to infinity e to the power minus pt f of t dt, which is what? Which is the definition of the Laplace transformation. This is e to the power minus ap. This is our f of t. So it's very easy to simplify this. So you can, if अगर आपको याद नहीं रहे, if you don't remember the formula of the second shifting property, so you can go through the basic definition of the Laplace transformation. Now there is one more property which is called change of scale property. Change of scale property. It says if Laplace transformation of a function f of x is given by f of p, then Laplace transformation of function f of ax is given by 1 upon a f of p by a. What is our last change of scale property? Says if Laplace transformation of a function f of x is given by f of p, then Laplace transformation of function f of ax is given by 1 upon a f of p by a. Now we have proved this using the definition of the Laplace transformation. We can write it 0 to infinity e to the power minus px f of ax dx. Let ax equals to some function t, then x equals to p by a, d of x equals to dt by a. When x equals to 0, then t again 0. X equals to infinity, t is infinity, e raised to the power minus p. x is replaced by t by a f of t. This is dx is our dt by a. Now a is independent of t, तो it can now ये इंटीग्रल साइन से बाहर आ जाएगा, तो इट इज लाइक 1/a 0 से infinity can be written as e to the power minus p over a into t f of t dt. It can be written as 1/a. This is what, if we take this in bracket, तो 0 से infinity e to the power minus p over a t f of t dt. It can be defined as Laplace transformation of f of p over a. Our p is replaced by p over a, e to the power minus pt f of t dt is f of p. So here e to the power minus p over a t f of t dt is become f of p by a. This is our second shifting change of scale property. Thanks.